Hi kids, I'm Phil Nye, Bill Nye's brother. Bill couldn't make it today because he had other stuff to do. So today we're going to talk about the characteristics of water. And properties of water in the North Atlantic Ocean. So let's get started.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Okay, so today we're going to be joined by the famous oceanographer Wild T-Bone Ted. Let's go get him. Hey Ted, welcome to the show.
Hey, what's up? Hey guys, I'm here to talk about the chemical composition of the ocean water. The total mass of dissolved solid in seawater is called salinity, measured in practical salinity units, or it is called PSU. The ratio of salinity is 35 grams of substance in 1 kilogram of water.
Okay, thanks for that, Ted. Now, my assistant, Manya.
Hey everyone. Okay, so the density of seawater is higher than pure water, which makes ships such as the Titanic float easier, as it is considerably less dense than the ocean water. Also, temperature affects the density of water. The cold water in the ocean adds onto the density of the water. Well, the temperature of the coldest water in the ocean is 4 degrees Celsius, so fish can survive, but of course, not people. Oh, those poor people in Titanic. Okay. Bill, back to Bill Nye. Oh, those poor people on the Titanic.
Hi everybody, this is Professor Will. Well, you know, the night of Titanic, where it crashed into a huge iceberg, there's only one way that the iceberg would have been preserved in that way. Well, it's all because of the colligative properties of water, salt, and ice. Well, the preservation of the ice, the iceberg basically. Well, surrounding the iceberg is salt water, H2O and NaCl. The NaCl break up into separate ions, sodium and chloride. Well, basically, for water, there's vapor pressure reacting onto the ice, as well as ice's vapor pressure reacting onto the water. However, the ions in the salt water are lowering the vapor pressure of H2O. Well, since they're trying to be in equilibrium with each other, the ice's vapor pressure has to lower as well, which depreciates the freezing point of ice, which makes the whole solution of ice, sodium, chloride, and water really, really cold.
Okay, for this experiment, you'll need ice,
Water
a thermometer.
and some salt.
Let's start with putting ice into a measuring cup.
Then pour all the water in it.
Then stick your handy dandy thermometer into the ice cold water. And you wait.
Well, okay, it seems like the water evened around 0, give or take a few degrees. Well, the water freezes at 0 degrees, mixes with the water, basically 0 degrees. Now add the salt.
Here we go.
Oh, look at that.
Let's wait. Enough of that. Well, looks like the temperature is -5 degrees Celsius.
Whoa.
Oh,
I know.
really?
Well, I wonder why. Well, of course I know why, I just explained it. Well, when you pour salt into the water, the ions separate, which forms Na, sodium, and Cl, chloride.
You're so smart.
Thank you. Well, when the ions mix separately in the water, they lower the vapor pressure of the water. But the water is reacting with the ice, and the ice is reacting with the water as well. So since the vapor pressure of the water decreases, the ice has to decrease along with the water because they're trying to reach equilibrium with each other. So the temperature of the ice decreases as well, which is below zero, -5 degrees. So it depreciates the freezing point of water. So the mixture of salt, water, and ice forms a much lower temperature than actual 0 degrees freezing point water.
Oh, I didn't know that before.
You must have done a lot of research.
I know.
Or maybe
Thanks.
paid attention in class.
Probably.
Yeah, we should.
Hey, let's go see what old Bill Nye is doing.
Right, let's go.
Yeah, let's go.
Bill Nye is dead. Oh, you're here. Okay, so last topic of today will be ocean currents and weather. Ocean currents are gigantic movements in the Earth's oceans generated by a few factors: temperature differences, the moon's gravity, and wind. So, temperature differences in water mean that there are more dense and less dense parts of the ocean. There's the warm water, which is going to wind up coming up near the top of the ocean, and cold water sinking further down in the ocean. That will generate movements in the water, and those will turn into currents. Then, as far as weather, there's wind that blows the water in a certain direction, and there are certain winds called trade winds that always blow in a certain direction, and then they're located all around the Earth's oceans. Then there's the moon's gravitation, which also has an effect by pulling the water with gravity in a certain direction, which will also contribute to currents. One important current is the Gulf Stream, which runs from the eastern U.S. up the Titanic route up to around England and northern Europe. And that current warms northern Europe up so much that, well, if it weren't there, there'd basically be polar bears living in Ireland. Anyway, that's all for today. And yeah. I'm cooking now. Okay, right.
Bill Nye the Science Guy.
Bill Nye, the science guy.
Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye.